Let's go ahead and try these problems. I recommend you copy these problems down, try them on your own, pause the video, try them on your own, and then come back when you're ready and we'll review them together. So on A, notice you have a radical in the denominator. We want to rationalize that denominator. So first thing I'm going to do is I am just going to break this up. I have the 5th root of 7 in the numerator, and I have the 5th root of 16x cubed in the denominator. Now, I want to make this in the denominator. I need to multiply by some number that when I do, I'm going to get a perfect 5th root in the denominator. So let's take a look at what we got. We're just going to jump right into this. I've got a 16. Well, I know the 5th root of 32 is 2. We've used that one frequently. And I also know that if I multiply 16 times 2, I get 32. So I know I'm going to want to multiply by the 5th root of 2. And now here I have x to the 3rd, but in order for this to be a perfect 5th root, it needs to be x to the 5th. Well, I am x squared shy. Remember, when you multiply, same basis, you would add the exponents. So I need an exponent of 2. So I'm going to multiply numerator and denominator by the 5th root of 2x squared. Remember, same index. You can just multiply what is underneath the radicals. So I have 7, 5th root of 7 times 2x squared all over. And in my denominator, I get 5, 5th root, 16x cubed times 2x squared. And now let's just keep cleaning this up. 7 times 2 is 14. I get 14x squared all over the 5th root. 16 times 2 is 32. X to the 3rd times x squared is x to the 5th. Perfect 5th root. So here we go. Final step. 5th root. I cannot simplify 14x squared. 5th root of 14x squared. That's going to stay. And in my denominator, the 5th root of 32 is 2. And the 5th root of x to the 5th is x. Let's take a look at B. Now on B, I have an index of 4 here and an index of 2. My roots are not the same, so I cannot just multiply what's under the radicals. What I'm going to do is I'm going to move these into rational form. So here I have 27x squared. My index is 4, I've got an exponent of 1, so this is raised to the 1/4 times 3x raised to the 1/2. And again, what I want to do is I want to create the same index. In other words, I need to get my denominators to be the same. To do that, I'm going to go with a denominator 4. So if I multiply my fraction here, 2 over 2, I'm going to get 2/4. And then I will have the same index. 27x squared raised to the 1/4 times 3x raised to the 2/4. Now, it might be tempting to go ahead and try to use your properties of exponents to distribute this 1/4 over, but understand if you're taking the 4th root of 27, it's not going to simplify all the way. So what we're going to do, we're going to factor out this 1/4. 27x squared times 3x I'm going to move that 2 in. Let me do this as a bracket. 3x, I'm going to keep the numerator here. And then what's going to be left is 1/4. So let's keep cleaning this up some. I'm going to have 27x squared times 3 raised to the 2nd power is 9. X to the 1st raised to the 2nd power is x squared. Everything is raised to the 1/4 power. Now, sometimes it's easier almost to kind of keep them like this and factor them a little bit more, because you know we're going to be looking for the 4th root. So we're going to be looking for 4 of the same factors. I've got factors of 3 appear in 27 3 times, and 9, it appears twice. 3 appears twice. So you know what? This is what I'm going to do. Let's move this into radical form here. That might just be a little bit easier to see. 27 times 9 is 243, which is at 3 to the 5th power, but I don't know how many of us really see it just like that. So this actually might be a little bit easier. So remember, 27 is 3 times 3 times 3. 9 is 3 times 3. Now, your x's, you have x squared times x squared, same base, you're multiplying, you would add the exponents. And so you get x to the 4th, which you know that already is a perfect 4th root. So here what we're going to do now is, again, remember when you're simplifying, you're looking for sets of 4 of the same number. So I have 1, 2, 3, 4 3s. And again, here, this x, because technically this is x times x times x times x. That's a group of 4. And remember, your index will cancel out the exponent. So when I simplify this, I can take out a 3, and I can take out the x. And what is left is 1, 3. I guess I didn't need to draw my radicals so far. So here's our final answer. 3x times the 4th root of 3.